Alright, today's integral is pretty long, and there's probably a faster way to do it, but I couldn't figure it out, so here's the brute force way of solving this. So it's the integral from 1 to e squared of the natural log of x to the natural log x minus 6, all plus 5, all multiplied by x squared. So the first thing we're going to want to do is use our only formula up there today, ln a to the b equals b ln a, and we're going to use that to simplify the inner portion of this logarithm right here. So we can turn this into ln x minus 6 multiplied by ln x. And then we'll have this plus 5 still, and then everything's multiplied by x cubed. And so the first thing we're going to do from here is we're just going to distribute this natural log in. So we'll have integral from 1 to e squared of natural log x squared minus 6 natural log x plus 5, and then everything is multiplied by x cubed still. And now we're just going to distribute this x cubed in. So from there, we'll still have the same balance of the integral, but it will be x cubed natural log x squared minus x cubed, or 6x cubed natural log x plus 5x cubed dx. And we're going to need a lot more space here, so I'm going to simplify this down for you. Okay, so it's the same thing as before. I just rewrote everything, and I split up all the terms by the plus and minus signs, which we're allowed to do by integral properties. So the first thing we're going to want to tackle is this integral, x cubed natural log x squared. And to do that, we're just going to do integration by parts, di method, of course. We're going to differentiate natural log x squared, and we're going to integrate that x cubed. Now, integrating x cubed, we will get x to the 4th over 4, and differentiating ln x squared, we will get 2 ln x. Don't forget the chain rule, so it will be all over x. So the first part of our answer will be this term right here. It'll be x to the 4th over 4 times natural log x squared, and this will be evaluated from e squared to 1. Now the next part of our answer is going to be this bottom two terms multiplied together. So they'll be minus 1/2 times the integral from 1 to e squared of x cubed ln x dx. And the important thing to notice here is that this integrand is the same as this integrand. So we can combine those terms to get, so this is 1/2 and this is 6. 6 is the same as 12 over 2. So 1 over 2 plus 12 over 2 is 13 over 2. And they both have a minus sign, so we will get minus 13 over 2 times the integral of 1 to e squared of x cubed ln x. Okay, everything's cleaned up again. Just box this part because this is the first part of our answer. We will now tackle this integral term. So to do that, we will also do integration by parts again. I'll just move over to this side. So di method again, we will differentiate our natural log x, integrate x cubed. Integrating x cubed, we'll get x to the 4th over 4 again, and differentiating ln x, we'll get 1 over x. So the first part of our answer will be this diagonal again. So it will be, let's move back over here, it will be x to the 4th over 4 times ln x. But don't forget this constant out front, so we have to multiply that by negative 13 over 2. And then we will subtract this part, which is minus 1/4 times the integral of x cubed. Yeah. And both this is evaluated from 1 to e squared, and so is this part. And don't forget, we still have to multiply negative 13 over 2 to this integral, so the negative times the negative is a positive. Then just multiply this by 13 over 2 dx. And now we'll clean things up again one more time to just box this part of our answer, as well as to combine this integral with this integral. Okay, we're approaching the end here. We just got this last integral here, which I got from combining this x cubed integral with one we had before doing our other stuff. And so let's just simplify this real quick. That will be x to the 4th over 4. Multiply that by 53 over 8, and then evaluate that from e squared to 1. And so now we have all of our parts of our answer. And so technically this is done, but we will just go plug in everything and then simplify it all down now. So the final long term for the answer without plugging in the bounds is x to the 4th over 4 multiplied by ln x squared minus 13 over 8 times x to the 4th ln x plus 53 over 32 x to the 4th, all evaluated from e squared to 1. So if we start plugging in stuff, so plug in e squared to here, that'll be e to the 8th over 4 times natural log of e squared, which is going to be 2, and then square that, we will get 4, minus, plug in e squared here, we will get 13 over 8, e to the 8th, and then ln of e squared is just going to be 2, so multiply that by 2, and then plus 53 over 32 times e squared to the fourth is going to be e to the eighth once more. Now we will subtract, plugging in 1. And so we could plug in 1 here, but notice ln1 is 0, so this term just cancels. We plug in 1 here, again, ln1 is just 0, so that cancels. Plug in 1 here, it's just going to be 1, so we will minus 53 over 32. And that's all for the second term. So if we start combining things, we will get this 4 and 4 cancel. This 2 cancel with this 8 to make a 4, and that has no cancellations. So all in all, this is e to the 8th minus 13 over 4 e to the 8th plus 53 over 32 e to the 8th, all minus 53 over 32. Now if we notice, our common denominator is going to be 32 combining all of this, so we'll just have to multiply this first term by 32 over 32. So 32 e to the 8th over 32. This one we'll have to multiply by 8. That will be minus 104 e to the 8th over 32. And this is still just plus 53 e to the 8th over 32. And then minus our 53 over 32. Combining this, we will get negative 19 e to the 8th over 32 minus 53 over 32. And then after all that, we finally have our finished answer.